Hello, welcome everybody. My name is Nick. I am a headless wanderer again on this broadcast. Always technical difficulties, it happens. So we have three other lovely heads here. Three of our core developers that will be going through updates during this town hall. We will try to keep it not too long, and at the end, also Adam is going to be doing another practice run of a very short version of his EggCon developer speech. So we want to begin off, I think, with an announcement about some of the Solidity stuff that we're going to go through. I'm going to talk a little bit about our bug bounty, and we'll mention any other updates and introduce Satyam also. So actually, Satyam, why don't you go ahead and give a hi?
Hi, guys.
Satyam is part of our team, and he's being very generous to join us very late at night over in his time. So many thanks to him. And when it's your go up, Satyam, please introduce yourself and give a little bit of background. Pablo, why don't you go ahead and kick us off with any updates that you have?
Yeah, sure. Hey, everyone. Welcome to our third town hall or fourth one? I think, yeah, third one. Yeah. So this week we have been working on updating our smart contracts based on the latest release of Solidity. Satyam is going to be talking about that in a few minutes. I also wanted to remind you all that we released our thorough version like 2 weeks ago, and this week we are going to be releasing a step-by-step guide on how to actually deploy your own tokens to our using Polymath on Robsten testnet. So keep an eye for that article that's coming out later this week. And next week we are going to do on our next town hall where I'm going to guide you through live on how to do it.
So Pablo, that'll allow anybody to come onto our test net, to the public test net, and register fake tokens on kind of a real contract, but a fake contract, right? Correct? And so you would put fake ether in, and you would get fake tokens back, correct?
Exactly. Yeah. So right now we have our contracts, the contracts that make Polymath network available on Robsten testnet. Using this guide and well, what I'm going to show you next week, anyone will be able to use these contracts to deploy their own, register their own token symbols, and then deploy the token without any total supply for the moment. But then on the following release of this guide, we are going to go through the process of whitelisting shareholders and minting token for them. And then on the last article, we are going to cover how to actually launch an STO, an initial offer for the token, and then whitelisting investors so they can buy tokens from the offering.
Sure.
And that's pretty much on my side. Do you want to talk about the bug bounty, Nick, or should we jump to Satyam?
Let's jump to Satyam because I want to load up a screenshot of the bug bounty. But Satyam, why don't you go ahead and introduce yourself, give a little background, and what you've been up to on the development side of the team.
Thank you, Nick. I'm Satyam Agrawal, and I'm working since November 2017 with Polymath and helping them to building the smart contract protocol that includes the SC20 as well as the KYC provider compliance contracts and all those STOs stuff. So me, Pablo, Adam, we are building that protocol. And for the latest release of the Solidity, that's 0.4.23, we make our protocol compatible with that latest release version that includes lots of improvements, and the major improvement is the constructor. And in the earlier release, you need to make sure that your constructor name should be the contract name same. But in the latest release, you only need to use the keyword constructor to mention the constructor function. So it will avoid all those bugs that may lead to change the contract name, but not with the constructor function. So adding into this, we also add the error strings or the reason strings in the revert and require statements that will ease the life of the developers who are going to build the application over the Polymath core protocol. So you do not need to worry about the typical VM revert errors that the developers always getting. They always get the specified error strings, so they can easily debug all those problems wherever the failure cases. So and in the 0.4.23 latest release, there's a lot of gas reduction in the array operations, as well as we can also return the dynamic strings or arrays in the function calls. So this is whole much about the in a nutshell, we can say this is a major improvement in the 0.4.23 release of the Solidity, and we are successfully compatible our protocol with that release. So this is pretty much with the release side.
Yeah, I think I think that the thing that really stands out for me is the being able to return error strings along with when a transaction does fail. I think building UXs or building UIs on top of blockchain is definitely challenging. Providing a great user experience, and I think that particular feature helps a lot there. Being able to kind of tell the user when something does go wrong, being able to tell the user exactly what went wrong is definitely a major kind of step forward in making the Ethereum or making smart contracts on Ethereum that much easier to interact with and kind of understandable.
Great, thanks, Satyam. Is that are you done now?
Yes, Nick.
Thank you for the update, and I know that we had some questions around what that meant, and that's a good explanation of some of the added abilities of of Solidity, which is underpinning some of our technology. So thanks.
Mm-hmm.
So I'm going to try and share my screen here. You guys can let me know if you see it. Do you see that browser?
Yeah.
So we've just posted this today. I guess more formally, we had planned to launch this tomorrow. We'll probably have some kind of Medium blog post, but I can go ahead and mention this and show this. It's at a good enough place to show this publicly. We have a bug bounty up with many thousands of dollars worth of ETH. Any developers out there who want to help us securitize and solidify our no pun intended, our Solidity contracts. We're looking for anybody and everybody to come and look at and pick apart our open source code that's out there. This isn't an issue on top of our GitHub Polymath core repository, and it explains which files we want people to go and look into, which source code, which Solidity code, what they do, examples, how we classify different bugs, and then the rewards. So we have a critical being 10 ETH all the way down to 1 ETH, and a submission process as to how to go through that and everything. So if you have any questions, feel free to reach out or to come on to this GitHub issue. We'll be announcing it more clearly with the link and everything on blog post tomorrow on Medium, Polymath Medium. So I just wanted to show that, and that's off now. Adam, did you have any regular updates before jumping into your slideshow?
No, not really. No, I think so. I think that the bug bounty is really exciting. I think it's a great opportunity for developers out there to kind of come up to speed and obviously, hopefully, or either hopefully or not hopefully, but hopefully find some bugs and kind of claim some of those bounties. We're really keen to get that feedback on the code, and definitely if you have any kind of questions, like technical questions about why bits of the code are written as they're written, or some further explanation or something isn't very clear, then reach out to us in the normal channels. We'll be very happy to kind of help clarify anything. And other than that, happy hunting.
Yeah, I'm sure you. It's a double-edged sword. You wish they could. You want them to help us and find errors, but you also don't want to be inundated with bugs that you've created.
Yeah.
But I'm sure we'll be excited to have anybody come in and help us in any way that they can. So I'm going to take that off the screen and hand the mic off and the screen off to Adam here, and he's going to give us I believe a quick 10-minute jump through of your modular Solidity presentation. Correct, Adam?
Yep. Okay. I'm just going to.
If anyone has any questions during Adam's presentation, feel free to ask them here on the platform, and we'll answer them.
Yep. Is my screen the presentation showing? Hopefully it is.
We can see it.
Yeah, it is.
Yep. Perfect. So so thanks very much for tuning in again this week. We're going to give another kind of quick preview of a talk we're excited to present at EdCon I think it's next week or the week after, about modular security tokens. So I think to start, it's useful to look back a little bit at how the ICO market and tokens have developed at a technical level over the last 12 months. So back in 2017, most ICOs were pretty much a free-for-all. There were no whitelists, there were no kind of pre-registration requirements, and really there was just kind of a novel way of fundraising and building a community and network effect. And there was some kind of interesting, from a compliance perspective, but also from a network perspective, we saw with some of the larger ICOs some kind of serious network or Ethereum network degradation due to the volume of transactions during some of those ICOs. As 2017 kind of progressed, we started seeing ICOs becoming a little bit more sophisticated, and we saw this kind of concept of a whitelist being introduced. So broadly, you would go to the organization's webpage ahead of the ICO, register your details, provide some form of kind of documentation or something, and your Ethereum address would be added to a whitelist, which was just a sort of simple list of Ethereum addresses. And the ICO contract then ensured that only addresses on that whitelist were able to kind of send Ether in and get tokens back during the ICO period. So I think this was introduced for a few reasons. It was certainly a nod towards compliance, and there was some kind of KYC, some know your client stuff going on. It also helped diversify investors. If you wanted to have a cap per investor on how much Ether can be contributed, it helped avoid Sybil kind of attacks for that, and it helped build up a certain amount of kind of FOMO ahead of the token generation sale, certainly for capped whitelists. So so I think it's also worth touching very briefly on what a security token is versus a utility token. So a security token, and this is obviously a kind of complex legal and regulatory area, and this is a very broad overview, a very quick overview. So a security token, it represents some ownership of a real asset, so some off-chain real-world asset that you own some part of. Investors in security tokens expect some sort of a profit, and as a result, the kind of ICO, or as we call it, STO, security token offering, is regulated. So you have to know who your investors are at a kind of broad level. Conversely, a utility token gives the token holder access to some protocol or some service. So really, the purchaser is just purchasing access to that service by buying the token. And as such, there's sort of lighter regulation for utility tokens. So at Polymath, where we're obviously focused on security tokens, we've been looking at the ERC20 token specification, which is obviously the most kind of common and widely implemented token specification, and what some of the sort of deficiencies are in that spec with respect to security tokens. And we think there are kind of two key areas where there could be some improvement. So the first area is that ERC20 doesn't offer any kind of interface or facility to check the validity of a token transfer, other than the kind of suck it and see method, where you just try to transfer tokens from one person to another person, and it either succeeds or it fails. But there's no way on chain of checking whether that transfer will succeed, other than just sort of trying to execute the transfer. So that's one deficiency, and I think particularly with security tokens, where there are usually much higher transfer restrictions in terms of who's allowed to buy and who's allowed to send and receive the token, and that those transfer restrictions apply, importantly, not just during the ICO period, which is what we tend to see before, but also through the full life cycle of the token. So that's one area we think where clarity could be improved. And then the other area is around how tokens are kind of issued or created or minted. So ERC20 doesn't say a huge amount about this, and I think in the wild we've seen tokens and ICO contracts take very different approaches to this. Some tokens initialize a total supply of the tokens and then sell them off. Some start, maybe they initialize, say, a pre-sale amount of tokens and then create new tokens as they're sold. There's no kind of standardized way through which new tokens are created or destroyed. And for security tokens, where tokens do represent some ownership in a real-world asset, that's obviously kind of more important. To touch on quickly why it's important to have standards, I think ERC20 is a great example of this. Standards really helps drive adoption. So if the fact that all tokens conform to the ERC20 standard is really allowed the kind of ecosystem to flourish, whether that's wallets or exchanges or various other kind of third parties and dApps that interact with tokens, they all know they can interact with tokens regardless of what the token is through a standardized interface, and that exactly the same kind of process applies to security tokens, which is why we're kind of keen to establish a standard. Okay. So yeah, a quick look at what the SD20 interface looks like. So one important thing is that it derives from the ERC20 interface. So in that sense, it's kind of fully backwards compatible. Any SD20 token is sort of by definition also an ERC20 token. And then in terms of so it is an interface. So it doesn't say anything about the way these functions are implemented, exactly the same as the ERC20 interface. So the first function, verify transfer, that's very much addresses the first problem around being able to verify a transfer of tokens without actually executing that transfer. So maybe a kind of clear example of this is, if you suppose there's an exchange which wants to check that Bob is eligible to purchase a security token, before allowing the purchase to go through, the exchange would call verify transfer with a from address of the exchange and a to address of Bob, to check that Bob is authorized to trade on the exchange, and as importantly, having traded on the exchange, is able to withdraw their tokens. And obviously, if that verify transfer call returns true, the trade is executed, and otherwise otherwise the trade is failed or doesn't execute. And it's worth noting that the trade may not actually involve a transfer of tokens if the exchange is using some internal ledger to kind of keep track of tokens until the withdrawal action happens. So the next few functions, mint and burn, address kind of the next problem. So the idea that the idea is that any either increase or decrease to total supply must go through either the mint or the burn function, respectively. So this kind of centralizes and kind of gives a clear view on where all tokens are created and destroyed, and that helps with things like regulatory reporting. Obviously helps a lot from the kind of clarity perspective as well. So that's the SD20 interface. So what are modular security tokens? So a modular security token is a Polymath implementation of an SD20 token, and the idea is that an issuer starts with a kind of bare bones SD20 security token, and the issuer can then choose modules from the Polymath ecosystem to add to their token to add additional functionality. So the sorts of functionality that the modules can represent, so they can represent functionality to allow you to restrict token transfers in various different ways. They can represent functionality to allow you to fundraise against your token, what we call STOs, security token offerings. Maybe there's functionality to add dividends to your tokens or voting. governance dual tokens and that type of thing. So you can think of it a little bit like an app store for token functionality where issuers can choose and pay for in Poly whatever additional functionality they need. So this has some great advantages. It lets us enforce the kind of SD20 compliance at a smart contract level. It gives issuers flexible ways to manage their transfer restrictions and other functionality whilst the issuer still remains in full control of their token. One thing I just wanted to touch on briefly. So, one of the kind of advantages of the blockchain is this idea that the smart contracts are immutable and can't be changed. And that, obviously, in terms of ICOs or STOs, gives investors some kind of guarantees around, for example, the number of tokens that will ever be created and that type of thing, which is important to investors. So the Polymath protocol, the modular security tokens, does allow that to happen. And the way it works is that an issuer, once they're comfortable, for example, that they've added all the STO modules they want to add to their token, they're able to lock the STO module type, which gives investors and other kind of other interested parties the guarantee that no further STO modules can be added to the token. So it won't be possible for the issuer to modify the logic that creates or mints new tokens in the future. So all of these modules live in the Polymath ecosystem, and we're keen to encourage third parties to develop their own modules. Modules have reputation based on which issuers have used which modules, and we're in the process of kind of putting together a clear set of guidelines and interfaces to help third-party developers create create new modules. So very quickly, I wanted to give a quick overview of what a module looks like. So this is an STO module. So I'm not going to spend too much time on it, but you can see there's a couple of interfaces you have to kind of conform to. There's the iModule interface that every module has to inherit from, and there's some kind of boilerplate code around how the module is initialized. So every module is created via factory contracts, which help us help us ensure that a particular module is always the same. A particular set of modules created from the same factory contract are all identical, but they can be individually configured or initialized depending on the kind of specific requirements of the security token. And modules can kind of interact with each other. So there are modules can, for example, reference. So an STO module could reference a permission manager module to check that a user has appropriate permissions and so on. Very briefly to touch on kind of areas we're exploring going forward. So we're looking at some of the newer token standards, I think particularly ERC 777, which help kind of token and DApp interaction. We're looking at integrating some of the new identity standards, which we're very excited about, into transfer managers, which are modules that help restrict token transfers, so particularly ERC 725 there. And we're looking at kind of generalizing and making the interaction between modules and security tokens more flexible in the future, to help really focused on helping third-party developers build their own modules. And then we also would like to improve the reputation system for modules, leveraging community involvement. So that's it. So our code is all on GitHub and open source, and there's a link there, but you can Google Polymath Network GitHub and see all the code. And as Nick mentioned, we're now running a bug bounty on that code as well. So that'll be, there's great reasons to go and take a look. And if you have any questions, please do reach out to us on any of our social channels. Thank you very much.
Thanks a lot, Adam. I don't believe that we've seen any other questions.
Thank you, Adam.
Feel free to reach out on, like you said, on any of the social platforms, on Telegram or anywhere, and we can get them answered. So I believe that brings us to an end, unless anyone had anything else. All right. Thanks a lot, guys. And
thanks very much.
Goodbye, everybody. Thanks a lot.